Hello everyone. So first, a lot of friends of mine are also asking me the question of how the memory allocate in the programming running process. So I have answered these questions for a lot of times, and I find a lot of persons, even the programmer with a lot of years experience, didn't have much understanding or thought about how the memory allocates a process. So today I will make a record to teach you during the program running how the memory allocates from disk, from memory, and from the program code. And I will take Java program, for example, to explain the whole memory allocation process for you. First, let's think a problem. So first, ignore this picture. I just draw this picture just now, so let's ignore it. First, let's think the question is that when we analyze a system, how can we know a system as quickly as possible? Actually, the most common method I use is to analyze the data flow of the system. And actually, there are lots of tools to analyze the data, to capture the data of the data flow. So based on data, we can analyze the system behavior and the system advantages and disadvantages. So this is a methodology to analyze the system. So in the area of program or in the area of the code, how can we analyze a program? Which is the best way to analyze a program? From my perspective, the best way is to analyze the memory allocation, or to analyze how the memory used by the program. Only when we understand the memory allocation or the memory use methodology by the program, can we really understand the program, can we really understand the code, and can we write a very good code, write out a very good application. So I use my spare time to make some video for you to explain such questions, and I will use Java language for example. In this series of videos, I will not talk about details of the Java language, but I will point out some very important concepts or very important understanding to help you understand and understand deeply of the program progress. And after you understand this progress, you will, no matter other language or no matter PHP or Python, you will also use this thought very clear. So realization work is not very important, but the thought is very important. So let's start. First, I draw these pictures, explain the process of the memory allocation work. So let's say first, this is the there are three parts of in my picture. The first one is the hard disk, and the other one is the memory, and then is the JVM. So I use the Java program. So I use JVM to make this example. Okay. This is JVM. How the JVM work? Actually, JVM works everywhere in the Java program. So first, we have a program, such as we have open up our Eclipse and type in some program, type in some code, and we store it in our hard disk. And then the first step is that we run this program, and this program will be loaded to our memory, okay? And there is will exist a part where we store our code from the hard disk, and at the same time, the operating system will manage our code and start to manage our resource and other management work. So what the operating system slide will do, first, it will find the main function of our Java program. And as we all know, the main function is the entrance of the Java program. So it will find the main function from this code and begin to run this code. So the operating system and the JVM of Java will cooperate together to allocate all the resource and other things and do all the management things for the program. So let's see the whole process. First, load to the memory, then the operating system read the code and find the main function from the code and begin to management the whole process. Then we will use the operating system and the JVM. We will find the code actually consists of different parts. In this static part, we can know this is the part variables. All the part variables stored in this static part, and all the new things. Actually, for example, when new object, all the new object instance will start in the heap memory allocation place. Okay, so the date segment will store all the static variables, and the character instance ones all will store in this part, and this part will store all this code. Actually, code segment also stores in the JVM part. Okay, so this is the whole memory allocation work. How does this work in the whole process? The stack stores all the part variables such as int a. The heap stores all the new variables such as new person. Okay. The data segment stores all the static variables. Okay. The code segment stores all the code data in this one. For the JVM, we also want to use this code. Okay. So these are the four parts of how the memory allocation works. So this is seems very abstracted. Let's see an example. Okay. I just draw this picture. Sorry for the Chinese word here. So why I use Chinese word here? Because there should be many Chinese friends will saw this video. So actually the static means 占内存 in Chinese, and the heap means the 堆内存 in Chinese. So if friends from mainland China, he will know what I mean by this picture compared with this. Okay, so let's say this is the logical process of the memory allocation work, and we can see this picture for an example. And actually there are file pictures here and explain the processing. This is an example. First, this is the main. First, let's say this program has been written by you and stores in the hard disk. Then you want to run this program, and the first thing to do is load this program to our memory. Okay, here's a part in our memory will store this code, and the operating system will at the same time will find the entrance of the Java program. This is the entrance of the Java program. Actually the main function. Okay, to find the operating system, find the main entrance, and tells JVM, okay, I find that the entrance, and we can cooperate together to do the management work of the memory allocation. So the JVM, okay, let's start. First, it finds this person P1 equals new person 122. Okay, this is person P1 is actually the part variables. Okay, just we will find this is the part variables. So the JVM will store the part variables in the stack memory part. Okay, it will store this P1 in the 占内存 Chinese. Okay, and what this this start means the actual address which is allocated by the operating system. So what the address is operated by the operating system, and we do not need to care about that. Okay. So first, when the program runs this line, and it will allocate the P1 to the static memory, and then it will find a new function. Then we said that now the new function will store our variables in the heap memory. Okay, so the new one will store these two variables 122 in the heap related memories. Okay, and this address will direction to this heap memory. Okay, then the same thing happens when we new a P2. Okay, P2 is a part variables. P2 is part variables, and the JVM will store the part variables in the in the static memories, and then the operating system will allocate address to this memory, and then when the code will new a person 223, and then we will allocate a new memory in the heap memory, and will assign the corresponding value to it. Okay. So until this part, we have got this memory allocation picture here. It is very easy. Okay. So let's see the second one. Then we have a new part variable named age. Okay. So this is a part variable, and this will be allocated in the static memory. Okay. Age 25. Okay. Part variables is okay. So this function is to set the corresponding instance age to this one. Okay, it's very easy to understand. So now we want to find the P1's age variable to 25. Okay. So here we saw the third picture. We will set the P1 first. The memory will first find P1. Where's P1? Oh, this is P1 in the static memory, and find the P1's address here. Oh, I see the address here, and through this address I will find what's stored in the unitary in the heap memory. So I find it in the heap memory, and I will find 8 here, and I will change the 8 here from 22 to 25. Okay, from 22 to 25. Okay. So this is how this works, and the same thing happens to the P2. Okay, actually I use plus in the P2. So in the first thing, it will first do this in this part. Okay, it will plus. So in this way, what the age is? Okay, 25. Okay, it will first set the 25 to the P2. Okay, the first thing happens. It will find the P2 and find the address, and through this address find the variables in the heap memory in the destination, and will assign the corresponding variables age to the 25. Okay, then the age variables will change. Okay, will change to 26. So in this will change to 26. Okay, it is very easy to understand, and the program has successful. So this is the whole process of Java programs called the memory allocation work, and this is an example for that. So somebody will ask me questions that, is this really very useful for us? So although I don't understand which part is allocated to which part, I also can run a program. So I want to say that is, although you can write some very simple program without knowing this memory allocation process or methodology, but in the Java program, this is a fundamental. Actually, if you want to write a good program, you must know the whole process. For example, I will ask a question: do you know what's the static method and static variables? This difference in Java program? If you know this, you will answer that very quickly. For example, what's the difference between static method and the instance method? Actually, static method will have the variables in the static. Okay, it is static. So all the corresponding variables will be allocated in this part. Okay, it is static. Static. What's the static? Hold on. So I will. So you will understand this one. Static method and the difference with the instance method. Okay. Actually, static method is one allocated in this part, or in this part. Of course, in which part? Static. Of course, in the date segment part. Okay, in date segment part. Actually, some books also refer to it in the static part. Okay, it is the same thing, but we can separate this. We can separate it so it will be more clear. So the static one will start in this part, and the instance one will start in this part. Okay. So what's the difference? When you new a class, when you want to use the instance method, you must new a class. Okay. You must new that object, and you can use that. If you can store it into this part, and this part is always in the memory, so you do not need to new the class. You can access to that instance method directly. Okay. Very easy. Okay. So the second one we want to know, what's the difference between the static variable and the instance variable. So what's the difference between this one? Okay. Just like the method, the static variables store in this part, and the instance variables stores in this part. So when we change we cannot change the variables in the static. Okay, if we add static in front of that variable, we can change the value if we use the instance variable. Okay, so if we understand all the process of the memory allocation work, we can know why we use static, why we use instance, and after we have know these two parts, actually not all the programmers with years of experience of Java coding know this process very clear. Okay, so after learning this process, after seeing these examples, after knowing what's the difference between static method and instance method, static variables and instance variables, we can see another problem we can solve after these fundamentals. So first we can explain that what's the guided allocation methodology in Java. Okay, it will each time it will clear this. Actually, it will use a TP thread to clear these ones, these memories information data here from time to time. It will conquer on this part, and it will clear all the guided information. It will clear all the guided data in his part. Okay, it will ignore this. So the length of the data here is fixed. Okay, the int is 32 bits and the 64 bits of the long, and the float is 32 bits, all the fixed ones. So the object, the instance ones is not fixed. So each time, from time to time, the Java will monitor this part and clear all the corresponding data in this part. This is the principle of the guided collection principle. Okay. So after understanding this one, we can also know deeply about how the Java program use the JVM to collaborate in the garbage and clear the garbage here. Okay, that's what the Java function, Java program use the use the guided collaboration methodology. How did you see it? So this is the highlight I want to point is that only when you understand the memory allocation work and the process can you write a good program, can write a good Java program. Okay. So there is another thing I want to point out is that if you want to use the static method, then the static method will always exist. So it will exist in this part, and the guided collaboration work will happen in this part. So if you use too much static, your memory will be bigger and bigger. So maybe if your application or program is too big, it will occupy all your memory at a time. Okay, so that maybe needs programmer to clear this date manually in your program. Okay, so this is the process of the memory allocation. I explain this process by a Java program, and this is an example of explained by the principles. And these are the two differences which confuse many people, many programmers. And I explain these examples by using this process. And actually, there is a thing we should conquer is that if we use too much static method or static variables, they are all in this, and it will occupy our memory from time to time. And maybe the guided collaboration work is all used in the heap part, and the programmer should should clear the data here manually. Okay, that's what we want to say today. Thank you. And I will make some other videos for you, and also take some Java program, Java code, for example. So I do not center on the details of the Java program, but I want to use the Java program to explain some programming thoughts to help you to write a better program. Okay, thank you.